Hello, friends. Welcome to our live broadcast. I'm Emily. Today's live stream focus on a core topic: conjunction of curved steel box girder bridge. These are unique shapes and excellent mechanical properties. Curved steel box girder bridge have been increasingly applied in modern bridge construction. However, their construction involves a complex process and technology, imposing extremely high requirements on construction quality and safety. To ensure the smooth, smooth construction and improve the energy quality of curved steel box girder bridge, this paper conducts an in-depth study on their key construction points, elaborates on the construction process, core technology, and quality control measures, and provides scientific basis and technology reference for relevant energy practices so as to promote the development and innovation of bridge construction technology. First, let me provide an overview of our company. Our company, Shandong Boyoun Heavy Industry Corporation Limited, was founded in 2016 and focuses on the R&D, fabrication, marketing, on-site technology services of steel formwork for bridge, viaduct, tunnel energy. The headquarters and the main factory are located in Binzhou City of Shandong, China, with international department located in Beijing. The annual output is more than 75,000 tons. Boyoun has been qualified by ISO QM system since its foundation. More than 30 patents have been approved each year. Yuan has served over 12,000 infrastructure projects, mainly for high-speed rail, expressway, railway, highway, and other large-scale infrastructure projects with experienced formwork solution. Cooperated with giant state-owned enterprises and well-known overseas construction groups. Over the years, we have gained extensive experience and expertise and built a strong reputation in the industry. We are dedicated to providing our customers with high-quality products and, more importantly, with excellent service and technological innovation. Okay, let's understand the construction process of curved steel box girder bridges. Firstly, the segmentation and foundation of the steel box girders. Segmentation of the steel box girder segments is determined based on bridge design, transportation conditions, and construction technology. Reasonable segmentation can reduce transportation difficulty and improve construction efficiency. Generally, factors such as curved radius and girder structure are considered to divide the girders into segments that are easy to manufacture and install. During the fabrication process, high-quality steel is selected and strict control is imposed on dimension accuracy. Advanced processing equipment and technologies are used to ensure that the geometric dimensions are and flatness of each segment meet the design requirements. Welding parts are pre-treated to ensure welding quality. From raw material inspection to finished product acceptance, strict control is employed in every link to lay a solid foundation for subsequent construction. Secondly, transportation and storage of steel box girders. During the transportation of steel box girders, appropriate transportation tools such as large flatbed trucks or buggies are selected based on the size and weight of the segment. The transportation routes must be planned in advance to ensure smooth roads or waterways and avoid jointing and collision. Prospective measures are taken to prevent damage to segments. The storage site must be flat and solid. Its dedicated storage spots installed, and the segments are stored in an orderly managing according to their serial numbers. Regular inspections are conducted during the storage period to prevent quality issues caused by minister deformation, etc. Different types of segments are stored separately for easy access. Reasonable transportation and storage method can effectively ensure the quality of steel box girder and the construction schedule. Thirdly, erection of temporary supports. Temporary supports are important load-bearing structures for steel box girder construction. Before erection, a detailed design is carried out based on the bridge structure and construction load. Appropriate materials such as steel pipes and section steel are selected to ensure the supports have sufficient strength, stiffness, and stability. In accordance with the design plan, process measurement and positioning are conducted, and strict control is imposed on the verticality and spacing of the supports. Reliable connections such as welding or bolted connections are used for the support joints. After erection, a comprehensive inspection and acceptance are carried out. If necessary, pre-loading tests are conducted to eliminate elastic deformation, providing a safe and stable supportive platform for steel box girder hoisting. Hoisting and position of the steel box girders. Firstly, hoisting and positioning of steel box girders. For the hoisting of steel box girders, appropriate lifting equipment such as large tower cranes or floating cranes is selected based on their weight, size, and on-site conditions. Before hoisting, the lifting equipment is fully inspected and debugged to ensure good performance. A reasonable hoisting sequence and to ensure good performance. A reasonable hoisting sequence and method are determined, usually starting from one end to the other, or from the middle to both ends. Reliable lifting points are set on the steel box girders, and protective measurements are taken. During the hoisting process, close attention is paid to the operation of the lifting equipment and the patrol of the steel box girders. Through pressures measurement, precise measurement and control, the steel box girders are accurately positioned. After positioning, temporal flexion is carried out in a timely manner to prevent displacement. Fifthly, welding and the connection of steel box girder. Welding is a key link in the connection of steel box girders. Before welding, the welding materials and the equipment are inspected to ensure that they meet the requirements. Appropriate welding process such as shielded mantle arc welding and gas mantle arc welding are selected based on the steel material and the welding position. Qualification verification is conducted for welders, requiring them to work with valid certificates. The welding process is opened in strict accordance with the welding procedure specification. Experiments such as welding current, voltage, and welding speed controlled. During welding, windproof and rainproof measures are taken. After welding, visual inspection and non-destructive testing are conducted to ensure the quality of the welds. For bolted connections, the bolt turning torque is controlled to ensure connection reliability. Lastly, construction of bridge deck system. The construction of the bridge deck system is carried out after the completion of the main structure of the steel box girders. Firstly, the bridge deck pavement layer is laid, and appropriate pavement material such as asphalt, concrete, or cement concrete are selected according to the design requirements. The flatness, thickness, and compactness of the pavement layer are controlled. The anti uh, the anti-collision guard rails must be installed firmly and strictly with an aesthetic appearance. The installation temperature of impatient joints is strictly controlled to ensure a good expansion performance. At the same time, the construction of the bridge deck drainage system is well done to ensure smooth drainage of the bridge deck, providing guarantee for the normal use of the bridge. The construction process of curved steel box girder bridge is a systematically interlinked project, from the section control of segment fabrication to the coordinated cooperation of on-site installation. Each process must adhere to specifications at the creation and quality at the core to ultimately achieve the safety and stability of the bridge structure. Next, I will further elaborate on the key technologies for curved steel box girder bridge construction and the full process quality control points, helping you fully master the core construction capabilities of this type of bridge. Let's focus on the four core technologies in the construction of curved steel box girder bridges, and in-depth analyze the key point of welding, hoisting, alignment control, and temporary support, design and construction, providing the technological reference for energy practice. Uh, Welding technology. One is the welding technology. It is of crucial importance in the construction of curved steel box girder bridges due to the curved characteristic of a steel box girder. The position and the angles of welding joints are more complex. First, it is necessary to accurately select welding materials and processes based on the steel materials thickness and welding position. For example, for high-strength steel, low hydrogen electrodes are often used to ensure the toughness and strength of the welds. During the welding process, welding parameters are strictly controlled. Excessively high welding current may lead to weld burn through and deformation, while exclusively low current may cause defects such as incomplete penetration, and the voltage must match the current to ensure arc stability. At the same time, the welding speed is controlled to ensure the penetration depth and forming quality of the welds. Considering on-site environment factors such as wind force and humi- human, humidity, humidity, and it is essential to take windproof, rainproof, and moisture-proof measures. In windy environments, wind shields are installed to avoid the interface of airflow on the welding arc. After welding, wearing inspection is carried out in accordance with relevant standards to check for defects such as undercutting, blowholes, and cracks in the welds. Subsequently, non-destructive testing methods such as ultrasonic testing and radiography testing are used to inspect the internal quality of the weld, ensure that the welding quality meets of the design requirements. Hoisting technology. Then hoisting technology, the hoisting of curved steel box girder is a high challenging task. Since the girder body is curved, its center of gravity is difficult to determine, and the posture of the girder body needs to be accurately controlled during the hoisting process of the meeting install requirements. When selecting hoisting equipment, comprehensive consideration should be given to the size, weight, size, hoisting height of the steel box girders, and the site conditions of the construction site. Large floating cranes are suitable for bridge construction in water areas, such as river crossing and sea crossing projects, with strong hoisting capacity and a wide operating rate, while on land Large tower cranes or corolla cranes are more commonly used. Determining a reasonable hoisting plan is crucial. Before hoisting, the lifting point position are determined through precise calculation to keep the steel box girder balanced during the hoisting process. Professional hoisting slants are used and strict inspections are conducted on them to ensure their safety and reliability. During the hoisting process, advanced marine instruments such as total stations and GPS compare the analyze them with the preset installation positions and adjust deviations in a timely manner. At the same time, professional commanders are assigned to ensure the coordination of all hoisting link and guarantee the accurate and safe positioning of the steel box girders. Alignment control technology and alignment control technology is a key technology to ensure the appearance and the mechanical performance of curved steel box girder bridges. During the construction process of curved steel box girders, the alignment will change due to factors such as self-weight, construction load, and temporary variation. Before construction, an accurate structure analysis model is established, which take into account the influence of various factors on the girder alignment, predicts the deformation of the girder box body at each construction stage, and formulates a reasonable camber setting plan. During the construction process, advanced measurement methods such as the total station measurement and level measurement are used to monitor the alignment of the girder box body in real time. After the steel box girder segments are hoisted and positioned, the deviation between their actual position and the design position is measured in a timely manner, and the causes of the deviation are analyzed. If the deviation exceed the allowable range, corresponding adjustment measures are taken. For example, methods such as adjusting the height of the temporary supports and tensioning temporary cables are used to fine-tune and girder alignment. At the same time, the influence of temperature on the girder alignment is considered, and the measurements and adjustments are carried out during period of stable temperature. Throughout the construction process, the alignment control plan is continually optimized to construction process. The alignment construction control plan and is continuously optimized to ensure that alignment of the bridge after completion meets the design requirements and guarantee the aesthetic and structural safety of the bridge. And as an important supporting structure for the construction of curved steel box girder, the rationality of the design and construction temporary support is directly related to construction safety and quality. When designing temporary supports, factors such as bridge structure form, span, construction load, and geography conditions are fully considered. Based on mechanical principles, structure calculations are conducted on the supports to determine the arrangement form, member size, and the connection method of the supports. Appropriate materials such as steel pipes and section steel are selected to ensure that the supports have sufficient strength, stiffness, and stability. During the construction process, the supports are erection in strict accordance with the design plan. The support foundation is treated to ensure that its bearing capability meets the requirements. Precise measurement instruments are used to control the verticality and levelness of the supports, ensure the erection accuracy of the supports. The connection of support joints must be firm and reliable. When welding or high-strength buoys connections are used, operations are carried out in strict accordance with the relevant specification. After the erection of the supports is completed, a comprehensive inspection and accordance are conducted to eliminate the interelastic emission of the support. Preloading tests are usually required. The preloading load is applied according to a certain proportion of the design load. During the preloading process, the deformation of the support is monitored. When the deformation is stable, the load is unloaded. The elevation of the support is measured again, providing an accurate supporting platform for the hoisting of the steel box girder. Quality control in the construction of curved steel box girders. Next, we will focus on quality control in the construction of curved steel box girder bridges and explain the key points of quality control in details. Whether it is the implementation of the process or the application of technology, quality control must ultimately be the core focus. Only by integrating quality measurement throughout the entire construction cycle can we ensure that the structural safety, service performance, and durability of curved steel box girder bridges meet the standards. I will focus on all construction stages, from raw materials to bridge deck system construction, and detail the quality control points for the construction of curved steel box girder bridges to safeguard project quality. Quality control of raw materials. The quality of raw materials for curved steel box girders bridges directly affect the structural strength, stability, and durability of the bridge. For steel materials as the main supporting material of the bridge, their quality is of crucial importance. Before procurement, on-site inspection of Suppliers should be conducted to understand their production processes and quality measurement systems upon delivery to the site. In addition to carefully comparing the quality certification documents with the design requirements, sampling for physical and chemical properties testing is also required to ensure that indicators such as yield strength, tensile strength, and elongation allegation of the steel meet the standards. The quality of welding materials determines the reliability of the connection between various components of the steel box girder. Damp welding materials or those with mismatched models may cause defects such as blowholes and cracks in the weld, reducing the overall structural performance of the bridge. Therefore, the storage environment of welding material must be strictly controlled, and their shelf life and appearance quality should be checked before use. For high-strength bolts, their quality is related to the tightness of the connection parts of the steel box girder and the force transmission effect. Sampling inspections of mechanical properties should be carried out by batch to ensure the uniform of the torque coefficient and prevent potential structural safety hazards caused by void loading. Only by strictly controlling the quality of raw material from the source and preventing unqualified materials from entering the construction site can a solid foundation be laid for the high-quality construction of curved steel box girder bridges. Quality control of steel structural fabrication. In the construction of curved steel box girder bridges, quality control of steel structural fabrication is an extremely crucial link. First, in the steel plate cutting and blanking stage, high precision cutting equipment should be used, and the operations should be carried out strictly in accordance with the design dimension to ensure the flatness and perpendicularity of the cutting surface and reduce dimension deviations caused by cutting errors. The process must be carried out on professional assembly uh, jigs. Advanced position technology is used to accurately control the relative position of various components. The gaps at each connection point are strictly controlled to meet the process requirements and avoid stress construction caused by improper assembly. Welding as the core process of steel structural fabrication requires particularly strict quality control. Welders must possess corresponding qualification and perform welding strictly in accordance with the quality weld procedures. When multi-layer and multi-pass welding is adopted, the interpass temperature should be controlled, and the welding slag should be cleaned in a timely manner. At the same time, real-time monitoring of the welding process should be strengthened and non-destructive testing methods such as radiographic testing should be used to conduct a comprehensive inspection of the internal quality of the welds, ensure that the welds are free from defects such as cracks and incomplete penetration. In addition, after the fabrication of the steel box girder segment is completed, a comprehensive dimensions review should be conducted to check whether their alignment, lightness, and other indicators meet the design requirements. Only by strictly controlling the quality in each fabrication link can high-quality steel structural components be provided for the subsequent bridge installation. Quality control of steel box girder installation. The installation quality of steel box girder is directly related to the overall performance and stability of curved steel box girder bridges. Before installation, a comprehensive inspection and acceptance of the temporary supports should be carried out to ensure that their foundations are firm, their structure is stable, and their bearing capability meets the requirements. At the same time, the appearance, quality, and geometric dimension of the steel box girder segments should be rechecked to ensure they conform to the design standards. During the installation process, accurate measurement and positioning are crucial. Advanced measuring instruments are used to monitor the position, elevation, and alignment of the steel box girder in real time, and adjustments are made in timely manner based on the measurement data to ensure installation accuracy. During hoisting operations, the lifting speed and the stability of the crane should be strictly controlled, and the lifting points should be selected reasonable and to prevent the formation or collision of the steel box girder during lifting and transportation. The balancing quality of adjacent steel box girder segment is the key. The balancing uh, surfaces should be cleaned to ensure there are no debris or oil and other contaminants After the spalling is completed, welding and quality inspection of the welds should be carried out promptly, and the same high standard testing method as those used in fabrication process should be adopted to ensure weld quality. After the installation is completed, a comprehensive inspection of the overall alignment of the steel box girders, the elevation of each control point, and the tightness of the condition parts should be conducted to ensure that the installation quality of the steel box girder fully meets the design and specification requirements, laying a solid foundation for subsequent construction and the safe use of the bridges. Quality control of bridge deck system construction. The construction quality of the bridge deck system has important impact on the service performance and the durability of the curved steel box girder bridges. In the construction of bridge deck pavement, first of all, the quality of the pavement materials should be guaranteed. The material should be proportioned strictly in accordance with the design max ratio and the gradation of various indicators of asphalt should be controlled. During the paving process, high, pre- high precision paves should be used to ensure uniform pavement thickness. At the same time, the paving temperature and the rolling process should be strictly controlled to ensure the flatness and compactness of the bridge deck, thereby providing good driving comfort. Further installation of guardrails, measurement and setting out work should be done in advance to ensure the accurate installation position of the guardrails. During the installation process, the spacing and of the guardrail clamps should be controlled to ensure firm connection. The weld parts should be treated for rust prevention to ensure the overall stability and aesthetics of guardrails and provide reliable protection for driving safety. The construction quality of the drainage drainage system should not be ignored. The slope of the drainage pipes should be ensured to meet the design requirements to prevent water accumulation. The pipe joints should be tight to avoid water leakage. The location of rainwater inlets should be responsible to ensure smooth drainage, timely discharge of accumulated water on the bridge deck, reduce the erosion of rainwater on the bridge deck structure, and extend the soil life of the bridge. To sum up, the construction of curved steel box girder bridges involved multi-complex and crucial links, from the strict selection of raw material to the fabrication, installation of steel structures, and the construction of deck system. Quality control at each stage is directly related to the overall performance and the safety of the bridge. Only by accurately grasping various key points during construction, such as strictly control welding quality, ensuring hoisting precision, and emphasizing element control, can the bridge be guaranteed to have excellent service performance and durability. As a bridge formworks supplier deeply bound to quality control, we have always believed that high quality formwork is a prerequisite guaranteed for quality control, whether it is dimension accuracy in the steel structure fabrication stage or element adaptation in the installation stage. The formwork we customize can achieve high precision forming and high stability supports, reduce construction errors, and lower the difficulty of quality measurement. If you need a customized formwork solutions that adapts to your project's quality standards, please feel free to contact us.